Elma, did you miss last class?
Yes, I did. I was sick.
Now you got to keep that cowboy game down low because I'm trying to watch it too. No, I'm not. Amanda, are you there?
Yes, I'm here.
How are you doing?
I'm doing well. How about yourself?
You did good too, didn't you?
Yes, thankfully.
All right. Dylan. Dylan set a record. Dylan, did you want me to tell everybody a record you set? Is Dylan around? Dylan, are you there? I'm not going to set the record with Dylan. Can I tell everybody you set the record? You don't want me to? I won't. No, okay. All right. I won't say it. All right. Let me mark you down. But you did good on your score, Dylan. You did really good. In fact, I was shocked. You scored one of the highest in the school here. But Dylan, now I showed you missed last class. I guess that's correct. But you did good. Emma, you there?
I'm here.
And you did okay. You did real good. Erica, how about you? Erica, are you there? Erica Whitehead, moving on. Gabriel, are you there?
Yes, I am here. Hello.
Let's see. Did you get your work done? Gabriel?
Sorry, what?
You got your work done and you have your grade, right?
I believe so.
Holly, are you there?
I'm here.
And you did good too?
Thank you.
What about Hunter? He's already been, we got Hunter down. He's good. Hunter the Block. I like that hat. Marking you in, Hunter. And let's see, Indira, I got yours finally. You're good.
Hi. Sorry
So
for
Indira,
the thing.
you are you happy with yours now?
I'm just checking my number.
You're just looking at it.
Yeah.
Well, are you happy?
Let's take a time.
Nikki, are you there?
Yes, I am.
And you're happy, I'll bet.
Yes.
All right. You had a good score.
Thank you.
Joshua,
I'm here.
you did good too.
Thank you.
How about Lillian? Lillian, are you there?
I'm here. Sorry,
And
I'm driving.
now I did not get yours. Is that right?
I emailed it to you.
Something about it. It wasn't correct.
Okay.
Look, you might want to get with other folks and let's get together because you're no score. Monica, are you there?
Yes, I'm here.
And you did good.
Yes, thank you.
Reba,
I'm here.
you did good too.
Thank you.
And Rebecca,
I'm here.
you did good too. Rebecca, what do you credit your ability to get that high score? What happened?
I wasn't, well, I had to get help, I guess. What exactly do you mean?
Well, you got it right. What happened?
I was adding the point or 0.845 in the
But
total.
you got it right.
No,
right?
I finally got it right.
Okay, so you did good, right?
Yes, thank you.
That's the point. That's good. Ryan. Ryan Clutch.
Yes, I'm here.
And you did good too.
Thank you.
Sharon. Sharon, how about you?
Yes, sir. I'm good. Thank you.
You did very good.
Oh, thank you very much.
So, how's your brother?
He's doing good too. He just
Is
came after work and then we just, yeah, he often asks about you. How do you feel?
he?
Yeah.
Yeah, he's a good one. He's a hard worker. Vanessa, are you ran?
Yes, he is.
And you, Vanessa, you did good as well. So everybody here is doing pretty good. Marissa, my bricklayer person, Marissa Flores, are you here?
Yes.
Good. I missed you when I think last time or something. But you did unbelievable on yours, right?
I guess so.
Well, didn't you max it out? Didn't you score the highest in the class or something?
I don't even know the score.
You didn't even know the score?
No.
Oh, in that case, you flunked, Marilla. Sorry. I'm sorry. Dude, you got to look at eCampus and see your score.
I haven't checked yet.
Well, I would run to it like crazy and see it because you scored really good. Okay. Well, I don't want to embarrass myself anymore because I thought everybody would have looked at that, but let's see. Anybody else out there that I miss? Vanessa, did I get you? Cantula? Oh, yeah, I got you. Okay. Did anybody I miss out there? Any names? Gabriel, did I get you, Mulvaney? See if I got you.
Excuse me, sir. Can I know what is the highest score?
What is a high score?
Mm-hmm. Yeah.
A very high score is like 90, 95, 100. Those are
Oh,
high.
okay. Okay. I didn't know that.
In schools, the B range is like 80 to 90, 89. High
Mhm.
scores are anything above 90, I think, Sharon.
Okay. That's okay. Thank you so much.
Yeah,
Mhm.
you did good.
Okay. Thank you.
Dr.
Thank you.
Wickman, I'm here. This is Erica Whitehead. I had to switch devices.
Oh, let me check on you, Erica. Let's see if I got you now. Let's see. And I mentioned that you did really good too, didn't I?
Oh, I don't know, but thank you.
What? You guys are killing me. You guys, this is 10% of your grade. And I worked so hard on this to get sure that your grades would be posted before tonight's class because I thought everybody would say, well, Dr. Wick, what did I get? What did I get? What did I get? So I spent all day skipping other stuff to just do your class, thinking that everybody would be so happy because I did so well. But all right. I mean, I don't think anybody here got anything less than an A.
Thank you.
We are so thankful to you.
Well, not me. You guys did good. I'm just proud of you. I mean, can you imagine a class this large and no one gets less than an A? I mean, that's where we're at. I know some people ask me 100 questions. Some people set a record, and they did. But anyway, it's enough of that. I'm happy for you guys, and I wish other classes were like you guys. Some are, some aren't. But you guys are pretty good. Sharon's brother's class was pretty good too. But this is catching up. You guys are catching up a little bit. Warming up. All right, let me look on here what we're supposed to cover tonight. It says polynomial functions and their graphs. Let's see. Polynomial functions and their graphs. I'm getting there. Let me see if my calculator's still working. No, I did. It's a lot of work grading those things, by the way, and making sure they're all posted because I have to post them on paper, right here and also on the computer. And and anybody that just has an issue, get with your study buddy, or you guys know to work with each other. My whole deal is that you learn. Um, so that's all I want. And so anyway, we're on 3.2. I'm gonna get there. I know. What am I doing talking? There's a Cowboy game going on. Does anybody know the score? You gonna play by play? Nobody knows the score. Okay.
It's 6-3. The Cowboys are ahead.
All right, that's good news. I wish they'd win.
Yeah.
I like the Cooper, and I think that once our fearless leader gets back, the Cowboys will really be good. I really do. I think they got some stuff out there, and well, I don't know if Cooper is just hanging in there or what, but I think Dak's the man. But he gets hurt a lot. Anyway, here's AIDS. This is part. Okay, I'm off football. I'm sorry. So here we have. This is a polynomial function f of x equals. Now notice the leading coefficient is negative, and if this is for AIDS, what does that mean? It means that usually not good news with negatives. But you can see in some cases. Now, in the case of this, it means that the number of AIDS cases is going down. Now, once upon a time, people said that they weren't going down, even though it said they were going down, they just weren't being properly diagnosed. But this is a bar graph. And if I asked you what number correlated to 2011, most people wouldn't say 2052. Now, if you raise your hand, I can't see. You got to talk.
Yeah, so I don't see what you're doing right now. We only see chapter 1 text.
You didn't click on chapter 3.
So you don't get it?
We don't see it, yeah.
Oh man, thank you for telling me.
Yeah,
is that the
that's
Ryan?
why I raised my hand, yeah.
Ryan, you're good. Can you see it now?
I can see your face. Yeah, I can see it now.
We're good.
Yeah,
all right, this is a bar graph. All right, let's go on to the next page. Now, polynomial functions are where you have f of x. A function means that instead of y, you have f of x, or g of x, or y. I mean, it could be anything, as long as it's not pure y. Now, polynomial functions are those that have smooth and rounded graphing figures, like figure 3.13 in front of you. It shows you polynomial functions on the left and not polynomial functions on the right. That's an example of a graph that's not one, or actually two graphs. Now, this is the AIDS polynomial function. Notice that the graph on figure 3.14 to your left goes below the x. What happens in terms of something going below the x? What does that mean? It says the graph falls to the right below x. What does that mean? Anybody? Somebody?
It's negative?
Yeah, and that means it's not possible. Whoever said that is exactly right. And what it means is that what we have is a situation where we call model breakdown. It means the model shows how the disease functions, but at the very end, it goes negative. Well, you can't have a negative HIV disease situation. Hopefully, it will go to 0 where there's no longer a problem with it. But that's called model breakdown. Now, the leading coefficient is important if it's negative. Well, here right in front of you is really key information. Now, reading this and understanding this graph, or whatever this is called, this table, is kind of a challenge. Now, when it starts out with number 1, it says for n is odd. N means the exponent. If the exponent is odd and the a, or number in front of the exponent, is positive, the graph starts at the bottom and goes up, it's positive. If the a is negative, that's a negative exponent, and odd, it goes down. Now, if you have an even exponent and it's positive, then the 2 wings go up. If you have a negative leading coefficient, then the 2 wings go down. Now, I don't know if they can give you a better explanation. Let's take a look. All right, so look. This is an odd function, 3. An odd n, it's number 3. The leading coefficient is positive, so it goes from the bottom straight up. Boom. Look at number 2. Number 2, what is the exponent or n on this one? Can anybody guess? What is the n on number 2? Anybody? I hope you can see. Can you see number 2? N is the exponent. What do you see in number 2? Well, since everybody's so shy.
Couldn't it start at the top and then go down?
So example 2 is 3, 4, 5, 6. It has an n of 6. And it's negative, so it looks like an upside down W. Let's look at the next page. Oh, it doesn't show us. Well, what we need to do is graph it. Let's go. Yeah, let's do that. And you can always test this stuff. So we have negative 4x cubed, open parentheses, x minus 1 to the first power, or second power. So that gives you 5. Then x plus 5 to the 1, which gives you 6. So let's do f of x, of course, is y. We're going to graph it. Now, it's a function because it says f of x. Let's go to our calculator, and let's see if we predict what's going to happen. Let's clear all this stuff out. Y equals, clear that one out. We're going to put negative, that's this one here, 4, x to the upper arrow, and that's cubed. Push it out of that, and then times, we're going to put parentheses, x minus 1, x minus 1, close parentheses, and I think that was squared. Push that out, and then open another parentheses, and put x plus 5. X, let's see, plus, what? Gotta go back, plus. Oh, heck, it didn't give me the parenthesis. Hold on. Here's a parenthesis. There we go. Now our x, now our plus, and now our 5, close parentheses. Boom, we got it finally. And so the leading coefficient is negative, so we're predicting this will go like a U, but it'll have some deviations in between. It'll be upside down. No, well, it's an upside down U. Yeah, because it goes negative and it's even. Let's see. It'll do some stuff here eventually. Yeah, there it is. Okay, so you can't see all the way up, but can you see my arrow on your machine here? Can you see my white arrow?
Yes.
Yes.
So what it does, it goes up like this, and then up here, it turns around and comes back down here, up a little bit here, and then comes back down here. So this is generally speaking a U. Why? Because the leading coefficient was negative. Okay, that's good for that one. Example trace. Now, tell us what's happening here. Well, the leading coefficient is negative. So this is a different kind of graph. It's going to start at the top and go down. You saw that in the other example. So the blue button says, or the light bulb or the blue bulb or says that the leading quotient is negative, so it goes down. The degree is a polynomial 3 and it's odd. So it's kind of like a straight line going down. It won't be curving up and down. It will, but it doesn't go like a, well, I think we, let's see, what do they show? Maybe they'll show it. No, I don't think they show it here. But let me show it. I hate doing something and not showing it. I don't know if this will work on our calculator. Probably won't. And that's probably why they don't show it. It's just too long. It's too big. The numbers are too big. But it would look like this. It's a cube, so it's odd. It's a negative in front of it, so it's going to go like this, down. Evens go like this or like this. Odds either go down or they go up. This is a negative in a cube, so it goes this direction. And we saw that where it went below the x, and then we call that model breakdown because it can't really go below 0. So that's that one. Hopefully that makes a little better sense. Numero quattro. Now, this is negative as well. It's to the 4th power. This is a tricky one. This is, in fact, the windows that they show you to get this graph. But it's a 4 and it's negative. So if it's a 4 and it's negative, this is what it should look like. A 4 means it's going to go like this because this is even and it's negative, so it has to go down. Now you only see part of it. Why? Because your calculator is told to only show you part of it. Yeah, that's the problem here. So let's go to the next page. The next page says, now, well, I'm going to show you this in detail because I want you to really understand this and get this thing to move back. Ooh, darn it. There we go. I said the wrong thing. Okay, so what we're going to do for this one, example 4, we have a negative x to the 4th power plus 8x cubed plus 4x squared plus 2. We're going to put it in our calculator. Or at least I am. I hope you guys do. It's always good to do that stuff, I think. And we get used to it and you can ask questions. So I'm going to go to y equals again. I'm going to clear this one out and put in the one we need, negative 4 x to the 4th power plus 8x cubed plus 4x squared. If I make a mistake, let me know. And then plus 2. Now we're going to graph this. And you only see part of the graph. Why? Because our windows are not set right. You see what the book shows you a little bit. Oh, but this graph is smart enough to bring it back down. So it does. Pretty cool. See what our window says. All right. Well, anyway, you see it. It's good. So it did work. What they're making their point is that sometimes if your windows aren't set, you don't see the real graph. Here's why they use the, well, different numbers. But anyway, let's go to number 5. Notice this is a cube. So it starts on the left and goes up because the cube is positive. It might not seem like a line cube, but in fact it is. Why? Because it looks like this. In the cube situation, and it was positive, it starts here, does a few movements like this, ends up here. In reality, it goes like this. That's if we stretched it out. It has some bumps and stuff in it, but overall, it starts here, the bottom, and goes up, it's positive. That's what the leading coefficient tells you, and that's what the exponent tells you if it's odd. Let's take a look at the next one. Oh, there is more to this. They want you to find the zeros of this. So we have x cubed plus 3x squared minus x minus 3. Now, the zeros, you can, if you put this in your calculator, we can find the zeros. We can use trace, but let's just put it in. X upper arrow cubed plus 3x squared. Oh, my thing didn't work right. Cubed, push it out. There we go. Plus 3x upper arrow squared. Sometimes this calculator, you don't hit it just right. Minus x. This is minus x, and then minus 3. Well, let's graph it. Now, you can see where the zeros are. That's where it hits the x. It hits it at 1 spot, 2 spots, 3 spots. By the way, it also has a y-intercept. Let's just stop for a second. Going back to the problem, this is the easiest question of them all. What is the y-intercept in example 5? Can anybody tell me? And the y-intercept is determined if you make x 0. If you make x 0 in every one of those positions in example 5, what does y end up equaling?
-3.
-3?
Yeah. So -3 is your 0. That's the y-intercept. Now we're trying to find the 0. The y-intercept is rarely taught because it's so easy. Now, we said we're going to find the x-intercept by graphing. So there we are. We're graphed it. We graphed it. Yeah. And let's go to the table. Second table. We're looking for wherever the x is 0. Well, here's 1, 0, -3. Oh, by the way, here's your y-intercept, -3, 0. Let's see if we can find any other ones here. We'll go down. 1, 0, -1, 0. Those are all the x-intercepts. Look at that. All 3 of them are right there. Now, if you couldn't do that, and you graphed it, you could always use the trace. Boom. There's the y-intercept 0, 3, but you can move it and get it pretty close. That one there says -1 about 0. There it is, -1 about 0. And keep going. This should be -3 about 0. Now it's a little bit off because the thing doesn't land straight on it. It's not a perfect instrument, but if you had a choice and you knew on the exam, you could write -3, 0 about there, and so on. The other side's You could go all the way over to find the other one. Just keep going. It just takes time. Oh, a little bit back, maybe. It's somewhere in between there. 1 0 1 0 bound. Okay, so now the other way to do this. Let's do it the manual way. You say, Dr. Wick, I don't ever want to do it the manual way. Well, sometimes you may not have a choice. They may say you can't use it, do it a certain way. So the manual way. So we have here the problem x cubed plus 3x squared minus x minus 3. Of course, all this equals 0, so we're going to do that. We're going to group them. We're going to factor out x squared. We get x plus 3 in this case. If you have x plus 3 on the left, you have to have it on the right. What do you have to multiply 3 by to get negative 3? And it's a negative 1. So my factors are x plus 3 like this, and x squared minus 1 like this. This is the FOIL method. Now, this, by the way, can be factored. This is a difference of two squares. This is x plus 1 times x minus 1. That's an x. And x plus 3. Now, my zeros are whatever makes it 0. What makes this package here 0? Negative 3, because 3 minus 3 is 0. 1, because 1 minus 1 is 0. And negative 1. Those are your 3 zeros. So now you saw the computer way to do it, the calculator. You saw the manual way to do it. And let's go back to the book. Number 5. Let's look at number 6. Find the zeros of this one. This is a little bit different technology. First of all, it's a 4, it's even, and it's negative, so it makes an upside down W. You can put it in your calculator and get your zeros easy enough. And by the way, they're going to have 0, 0. That's the origin. That covers two things. That's your y-intercept and also an x-intercept. And then you have 2, 0. If you graph it, you'll get exactly what you see in the left, so I'm not going to waste your time. But you can see automatically right there that the x-intercept is marked with those 2 red dots. One is the origin, 0, 0. The other one is the 2. Now, manually, how do they do that? I want to show you this because it's a part of this of the learning process that you should know how to do. It'll be helpful to you later. So let me stop this. Let me go back to the board, the whiteboard, do this thing for you. And we have a negative x to the 4th plus 4x cubed minus 4x squared. And all this is equal to 0. Now, we want to factor out something with all of these. And you can see the highest thing to factor out is x squared. So if we factor out x squared, we get minus, actually, if we factor out a negative x squared, this becomes x squared here. This becomes minus 4x. This becomes plus 4. Because if you take that and multiply it out, that's what you get. X squared times x squared gives you x4, that's negative. Negative times negative is a positive, that gives you 4x cubed, and so on. Now we can factor these. X minus 1, x minus 3, and the other factor is a negative x squared. I used FOIL in my brain, got x minus 1, x minus 3. Why? Because 1 times 3 gives you 4, and a negative 1 and a negative 3 gives you negative 4, and x times x gives you x squared. That's done like this. This times this gives you the x squared. This times this gives you a minus 3x. This times this gives you a minus x. Minus 3 and a minus 1 gives you minus 4x. And a negative 1 times negative 3 gives you a positive. Uh-oh. That's not right. I factored it wrong. Should be negative 4. Let's see. Can you do that? Let me look. Negative 4. Negative 4. I don't think it's factorable. I think you have to use the quad. Let me look real quick. Let me just check because I don't want to do something. Probably unless I got something, wrote something down wrong. What did I write down wrong? 4x cubed. 4x minus 2 minus 2. Oh. Yeah, minus 4. Let me see if I got that written right. So it's x squared. Yeah, I can't see who's making the bumping. You just have to talk. X squared minus 4. Yeah, I just factored it wrong.
Dylan was saying maybe it's x minus 2
Yeah.
up to the second.
He's absolutely right. I like Dylan. He's gently doing it. Hey, Dr. Wick, you made a mistake there. Should it be so-and-so? Yeah. Don't do it again, though, Dylan. No, I'm just kidding. Just kidding. All right, let me clear this and fix this like it never happened. Okay, so we had a negative x to the 4th plus 4x cubed minus 4x squared. That is, in fact, equal to 0. I factored out the negative x squared. That gives you x squared here minus 4x and plus 4. And that factors to x minus 2 and x plus 2, or no, minus 2 again. X minus 2 again. All that equals 0. And this is x squared, and it's negative. So this is a 2, this is a 2, and this is a 0. Now, the thing that you should note, this, in fact, is really x minus 2 squared. Now, when you ever have a square, it only touches, and it always touches at that spot where it makes it 0. So that's 2. Anytime you have a square, so if you had x minus 3 squared, it would touch at 3. Now, let's just prove that first. Let me do x minus 3 squared. We'll hold off on this. Let's go back to the calculator. We're going to go to y equals, we'll clear this out. And we'll just write in parentheses x, what minus 5? What the heck? And upper arrow squared. And I said that it would touch at 5. Let's graph it. Boom, there you have it. It touches at 5. Now, let's do theirs. We said it was a negative 4x to the 4th. Again, you can all do all this stuff with your calculator. Plus 4x cubed. And minus 4x squared. And we're just going to graph it and see if it touches, just like we said. It's going to go through the 0. Something doesn't seem right. Let's go back to the y equals. We did something wrong again. Let's see. Minus 4x to the 4th plus 4x cubed minus 4x squared equals 0. I think that's right. see what the book says. Minus 4x cubed plus 4x, x to the fourth plus 4 minus 4x squared. And we get this. Now, what in the heck? Why don't we get that with our calculator? We got to get that with our calculator. Wrong screen. There we go. Boom. All right. So, did I put it in wrong? Minus. Oh, don't pay attention. Minus.
X whole.
X to the 4. That's right. I must be thinking too much football. Plus 4x cubed. And then minus 4x squared. Now, I think that's right. Let's graph it this time. Looking for the 0, 0 situation now, so the 2. Come on, calculator. You got to start working faster for me. There it is. There's the 0 and there's the 2. Since it was a square, it touches. And notice the x squared also just touched. So if we go back to what the book said or showed, let's see what our whiteboard said. Look here. Look at the whiteboard. We have the x minus 2 squared, which gave us the touch of the 2. But also, look at the x negative x squared right here. I didn't know you could do that. That's a square and that's negative, so that's a 0. All right. I don't know what happened there, but we got something going on. So we'll clear that out. Go back to the book. Next one, number 7. Multiplicity. The multiplicity, that's a test question. They want to know the multiplicity of an equation. Now, multiplicities of equations are either cumulative or you multiply them. So, let's look at what you see as a solution here. 1/2 x plus 1, parentheses 2x minus 3, and parentheses squared. Now, the x plus 1 has an exponent above it. What's the exponent of x plus 1? Does anybody know? It shows it right here in the blue bubble. Technically, there's a 1 there. So that has a multiplicity of 1. If you look at the 2x minus 3 squared, that's a multiplicity of 2. Now, yes, the overall multiplicity of this equation is 3 because you add them because they're multiplied. But if they weren't multiplied, it would be just the highest level one. So let me do this real quick. Let me give you 2. I think I can do this. I didn't know that. Oh, come on. So, let's write x plus 2 squared times x minus 3 cubed times x. The multiplicity of this equation overall is 6. Why? Because technically there's a 1 here, and you add them. Now, if I write this, this is a 1. The multiplicity of this is the highest one, and it's not cumulative, so it's 3 because it goes with the largest one since it's not multiplied. The multiplicity of this one is 2. The multiplicity of this one is 1. So it's cumulative when you multiply, but it's simply the highest level number if it's added. Very, very important. So quickly. What is the multiplicity of this one? What is the multiplicity of that equation?
Would it be 15?
No, it only goes by the exponent.
5.
Yes, it's 5. It's based on this. Now, because you have all these plus signs and things in here. Now, if I have this, what is the multiplicity of this one?
$12.
Exactly. You add them. When they're multiplied, you add them. Right. Now, the intermediate value theorem. What does that mean? This is the coolest thing. You have the equation x cubed minus 2x minus 5. This is a line. We can graph this. What I'm about to show you should be helpful. This is y equals x cubed minus 2x minus 5. So let's graph it. Get rid of this. Come on, what that was supposed to delete it. There we go. Boom. Now back to what we want to do. So we're going to go to y equals again, clear this all out, and put in the equation x cubed minus 2x, and then minus 5. And graph it. And that's what you get. Now, in the equation, if I pick a number down here and it's negative, and I pick another number up here, it's positive, if you have two different sign changes, that would be this. If I pick a point here, this is positive, positive. If I pick here, it's positive, negative. What can you say when I go from here to up here? What do you know for sure? If I travel along this line.
That the number's positive.
But what happens? What happens here?
It's the x-intercept?
It is, but it crosses the line, doesn't it?
Yes. Yes.
So if you have a negative here and a positive here, and if this line is continuous, if they touch each other, it must cross X, right? Here's my graph. Nah, no good. If I draw a point here and I draw a point here and I connect them, what does this graph do? It crosses what? I said it 100 times. What is a cross?
X. X.
Sharon's right. It crosses the X. Now look. Sharon, you gotta turn your mute on. Okay, thank you. That means, here's your equation, example 8. They give you two numbers, 2 and 3. Here's your equation. F of x, which is really y, equals x cubed minus 2x minus 5. Now, if we put in the equation 2, we get 2 times 2 is 4 times 8. That's 2 cubed is 8 minus 4 minus 5. We get 2 negative 1. That's the point we get when we plug in 2. On our graph, 2 negative 1 is right here. Now let's plug in 3. 3 cubed is 27 minus 6 minus 5. That gives us what? What's 27 minus 11?
16.
So 316 is up here. Since the line touches, it's continuous. It must cross the what?
X-intercept.
It must cross the X. It is an X-intercept, but what you want to say, it crosses the X. Look, if I put a number here, 2, which is 2 negative 1, and I put in 3, and I get 16, if the line is continuous, the graph is continuous, it must cross, and there must be an X-intercept in there. That's all they're trying to say. That is called the intermediate theorem. Intermediate value theorem. And that's what we're trying to show you. Now, turning points. Since in example 9, this is a 4 and it's positive. So it has a W, it has some stuff that happens in between. What is the y-intercept in number 9? Somebody should tell me right off the bat.
1.
Yes. Now, if you graph this, or if you factor it, you can see in the work, you do x plus 1 squared, which means you have a negative 1 intercept it touches. And you have an x minus 1, which is another touch. And the y-intercept is 1. It looks like this. It touches at the negative 1, it touches at the 1, and intercepts the y at 1. This is the ultimate of the problem. If you can understand number 9, you're good. I'm going to end on that note. Let me take my attendance thing again. See who's still around. Encourage those folks that have not completed the homework. There's a few. Again, our goal is not to hammer anybody. We want them to pass. So, help them if you can. Anybody, let them figure it out and help them figure it out. So, okay. Let me just see who I don't have. I think I did. Lexa Fernandez make it here? My bowler. Worried about Lex. Does anybody know her Somebody should send her a note and say we sure miss her. She can get caught up. That's my bowler. The Gillises.
Hello? What happened?
I don't know what.
I think he left.
You disappeared.
There he goes. We can't hear
I
you.
think something's wrong with the system. It was kicking me out too.
Can anybody hear me?
Okay, I can hear you and see you now.
You can? Okay, good. Let me finish this. Okay, Edith, yeah, that's good. So let me go down my list. Edith, can you turn your phone? Edith,
I'm here.
Edith, can you turn your thing off? Muted. Thank you. Thank you. Okay, so Jordan, is Jordan here? No, Jordan Guerrero. Let me see who else. Rosio Morales, never misses. Rosio, are you here? No. Angelica. Oh, Angelica. My teacher assistant, Edith. You're here, aren't you, Edith?
Yes, sir.
I got you. And then Venancio, are you here? No, Venancio. Let's see who else. So I'll just go down the list and see ones if you have any questions. Alma, are you good to go?
Yes, I'm good to go. You have a great night.
Good night. Dylan? Dylan, you're good. If you have any questions, does anybody, otherwise you can free to go when I call your name. Emma? Erica?
Yes, I'm good. Thank you.
Okay, Erica? Good. Thanks, Emma.
I'm good. Thank you.
Gabriel? Holly?
I'm good.
Thank you. Good deal, Holly. Gabriel? No, Gabriel. Hunter? You're got to stay on a little bit, but you're good. Indira?
I'm
Indira, you
good.
good?
Thank you. Good night.
Joshua? Thank you.
I'm good. Good night.
Good night, Lillian.
Unfortunately, I didn't have the opportunity to actually watch, so I don't know if I'm good or not, but I'll take a look back at the video. And then, are the student academic tutoring centers still open to or are they virtual now? Do you know?
No, you can go and visit them.
Okay. Because I feel like I'm touching base on these things and understanding them, but I guess not. Like some things.
Well, Lillian, are you able to attend the classes or you're on the road or something?
Yeah, no, I was coming back from out of town.
See, that's part of, when you can't see, that kind of affects you a little bit. But yeah, you can get help and don't give up. Let me see here. I don't have your, I don't have your homework yet either, right?
Yeah, no, I emailed it to you.
Well, we talked about that a little bit ago.
Yeah.
And did you get it right?
I didn't hear a response back from you, and I don't have a grade on my Blackboard.
So it must be you don't.
Okay, so did you want me to redo it?
Well, I have to see it. I'm looking here. Hold on.
Got it.
I can't tell you it's wrong if I don't see it.
Yeah, it should have came from Lily A. Hancock. I tried to send it from my student email, but it wouldn't send.
Oh, see, the system won't accept weird. Bullpen. And Lillian, I don't have it.
Try Lillya.
Try what again?
Lillya and A
Lily?
as an apple. Yeah, Lily. Yeah.
Okay, I got it then. And let's see.
I still think it's wrong, but I'm saying it's not.
I got a different Lily. I didn't get you.
Yeah, it should be me.
Yeah, and no, you have there for the present value of 17,900 over for it, so it's not correct.
Okay, all right, I'll email you. It's cutting out real bad, but thank you so much for your time.
Marissa, are you there?
Yes, I'm good. Thank you.
All right, my brick lady. Monica.
Yes, I'm here. Thank you.
Reba.
I'm good. Thank you.
Rebecca.
I'm good. Good night.
Good night. Ryan.
I'm good. Good night.
Good night, Ryan. And then Sharon.
I'm good. Thank you. Good night.
Good night. See you guys.
See you.
Bye.
See you soon. Bye bye. Have a good one.
Thank you all.